In this video, we're going to be talking about special types of parallelograms and their properties that are in addition to the 5 parallelogram properties that we just previously discussed. So each of these 3 shapes that we're about to talk about have those 5 properties, and in addition they have a few extra special ones. So let's get into it. This is a rectangle. It looks like a rectangle, but what makes a rectangle are these specific properties. So first of all, they got to have all the properties of a parallelogram. All the properties of a parallelogram. That would be that opposite angles are congruent, opposite sides are congruent, opposite sides are parallel, diagonals bisect each other, and missing one. Same side angles add up to 180 degrees. So in addition to those 5, a rectangle has these special properties. Each angle or each corner is a right angle or is 90 degrees. Okay. So that's 90 degrees, that's 90 degrees, that's 90 degrees, and that is 90 degrees. Also, what else here? Diagonals are congruent. So if I draw this diagonal, then the length of that diagonal right there is congruent to the length of this diagonal. Okay, so if we actually label our vertices here, then we can talk about it. So AC, that segment, is congruent to or equal to segment BD. And since they bisect each other because it's a parallelogram, well, each of these halves is also the same length as well. So diagonals are congruent. Their entire lengths are congruent. Okay. Let's just skip ahead here and do the example dealing with a rectangle, so we talk about the same thing all at once. So here we have a rectangle. If we draw all the little parts of this rectangle, here's a diagonal. Here's a diagonal. This is rectangle BRAT, or B-A-B-R-A-T, sorry. This is going to be angle 1 right there, angle 2, and angle 3. So that's what we got to find in this rectangle so far here. They say that angle 1 is 38 degrees. So if this is 38 degrees, how are we going to find angle 2? Well, one way is to look at the diagonals. We know that each of these little parts are congruent, right? If you start to look at the shape that's created down here, it's a triangle, and we have a triangle with 2 lengths that are equal. We know that is an isosceles triangle, and if it's an isosceles triangle, then we know that these base angles are also equal. So angle 2 is 38 degrees. Okay, so we had to apply the property of these diagonals being congruent. Think about an isosceles triangle, and we can figure out angle 2. And we figure out angle 3. Well, if that's 38 degrees, and we know this entire corner here adds up to 90 because in a rectangle the corners are 90 degrees, then angle 3 has to be what's missing from 90 degrees. So we know the total has to be 90. We know 38 of it. So what's the difference? What are we missing? Do a little subtraction, and you get 52 degrees. Angle 4, that's what we're missing. There's angle 4 up there. So again, think about these 2 diagonals being congruent, so their halves are congruent. And now we're looking at an isosceles triangle here on the right as well. So angle 3 and 4 are also congruent. So if angle 3 is 52, angle 4 must be 52 degrees. So kind of applying a lot of our geometry skills in that problem. Alright, let's back up here. Let's talk about a rhombus now. A rhombus, again, is a type of parallelogram, so it has all the properties of a parallelogram. And it has its own unique special properties. Pay attention here to the difference between a rhombus and a square. A square has 90 degrees, just like a rectangle, but this rhombus here is like a square except tilted, so the angles are not 90 degrees, but otherwise it acts just like a square. All sides are congruent, just like a square. So all of these sides are the exact same length. Diagonals, here's a unique one. Diagonal, let's spell it right there. Diagonals are perpendicular. And what does that mean? Let's draw it. So if I draw that diagonal, and I draw this diagonal, well, what happens in the middle, even though it's not drawn super correct there, but that happens to be 90 degrees. And really, each of these angles in the middle is 90 degrees because these two lines form a perpendicular intersection. So anytime you see a rhombus, know that any of these angles in the middle here are 90 degrees. Also unique to a rhombus is that diagonals bisect these corner angles. They bisect two angles. So this diagonal right here bisects this angle 1 and this angle 2. So that diagonal bisects two angles. This diagonal bisects this angle and that angle. So each diagonal bisects two different angles. So each of these little halves here are equal. They're not 90 degrees. This isn't 90 degrees being bisected, but whatever it is, this diagonal will cut it exactly in half. So let's try and apply those properties to this example of a rhombus here. Let's draw some diagonals. Okay, we're going to look for angles 1 and 2 there, and 3 and 4 over here, and 5 right in the middle. Tells us that angle 1 is 35 degrees. Okay. Well, so far we don't know enough information to get angle 2. Let's jump over to angle 5. That's the easy one. Remember, these diagonals form perpendicular intersection. Any angle right here is 90 degrees, so angle 5 must be 90 degrees. So that's 90 degrees. Okay, well, we know that this diagonal bisects this angle into two equal halves, so if 1 is 35, then 2 must be an equal half, so it must be 35 degrees. Now we have enough information to roll along here. Now look at this top shape. We have a triangle. Well, we know two angles in that triangle. Angle 3 is going to be that missing triangle, or the missing angle in the triangle. So we know 35 and we know 90, so that's 125 so far. We know we need a total of 180, so what are we missing from 180? What's the difference? Well, it turns out to be 55 degrees. So angle 3 is 55. Well, if angle 3 is 55, and this big angle right here in the corner is bisected into two equal halves, well, the equal half must be angle 4. So that must be 55 degrees as well. Alright, another way we could think about it is if we have 70 degrees over here, 35 and 35, and same side angles add up to 180, well, we're missing 110 degrees over here, and if we cut it in half, then we get 55 as two of the halves. Alright, so there's a rhombus. Let's talk about this last special type of parallelogram. Turns out to be a square, and a square has all of the properties. So every property that we've talked about. All the parallelogram properties, all the properties from a rectangle, and all of the properties from a rhombus. Okay. So let's see if we can apply all those properties to one shape in a square. Here's our square. Draw some diagonals here. We're going to be looking for angle 1 and 2 down there. Angles 3 and 4 here. think that's all we got to label. That's good enough. Okay, so right off the bat, angle 4, well, if it has the same properties as a rhombus, then that must mean that these diagonals are perpendicular, which means that any of the angles in the middle here are also 90 degrees in a square as well. If we go to the corners here, we know that each corner is 90 degrees, just like a rectangle is, right? And just like in a rhombus, this diagonal bisects the angle into two equal halves. So if you have 90 degrees right here, cut in half, then angle 1 and 2 must be 1/2 of 90 degrees. Well, what's half of 90? 45 degrees. Angle 3, well, if we know this is 90 here, and we know that up here we have 90 cut in half again, because that's got to add up to 180, same side angles. Again, we're just bisecting 90 exactly in half. So angle 3 must also be 45. Turns out that at each corner of a square, you have 90-degree angles, each being bisected by their diagonals. So at each corner of a square, you have 45 degrees for the two smaller angles there. That's just only true in a square. Alright, angle A, well, if we label our vertices here, C, A, L, and F. So angle A is talking about this entire angle up here. What's this whole corner? Well, in a square, all of our corners are 90 degrees. So really, those are our special properties. Talking about those 3 special parallelograms. So good luck applying those properties to finding missing angles and missing sides. I guess we got time. We could talk about sides. We didn't really talk about that. Let's say this side is 6. Well, segment CA, or side CA, must measure what? Well, in a square, all sides are equal. So if one side is 6, all sides must be 6. So that's pretty easy. And the sides of a rhombus here, if we know that this side measures 8, what does this side measure? Well, in a rhombus, all sides are equal, so that must be 8 as well. You could also apply your properties of parallelograms. Opposite sides are equal. Well, if this is 8, then that must be 8. And if this is 8, then this must be 8. So again, all sides are equal, and that's a rhombus. Rectangle, the difference here between a rectangle and a square, or a rectangle and a rhombus, is that all sides are not equal. Opposite sides are still equal, but they're not all the same. So if you know that this is 12, what's segment TA? Well, that has to be 12 because it's opposite, right? But this side over here is not going to be 12. It can be a different measurement. Let's say it's 8. Well, that would mean that this side over here is 8. So as you can see, all sides of a rectangle are not congruent. That's only true in a rhombus and square. Alright, that should be good enough. Good luck on special parallelograms.